So in this video, we're going to determine the amplitude and period of sinusoidal functions. Okay, so we're going to look at graph of y equal to cosine of x. Okay, so 1 to negative 1, 2 down to negative 2. So let's do pi over 2, pi, 3 pi over 2, 2 pi. And I'm going to copy this. Okay. And then in a second, we're going to do y equal to 2 cosine x. Okay. All right, so cosine x starts at 1, and then it works its way down to 0, and then we get down to negative 1, and then we work our way back up to 0, and then we finish off where we started. So we come down. Oh, let me try this again. We come down, and then we come up, and then we level off. All right? Now, the big difference between this one and the next one, well, you see the cosine of x is stuck between 1 and negative 1, okay? But what would happen if we doubled everything? So I multiplied by 2 on all of these. So let me do that. Okay. All right. So if I multiply everything by 2, what do I have? This tells me that 2 cosine x is stuck between 2 and negative 2. Okay? So in general, if I have some function, okay, so, some trig function, so whatever, maybe y equals to the sine of x, okay? If I have y equals a sine of x or cosine of x, doesn't matter, then that number, that output, a sine of x, is stuck between the absolute value of a and the negative absolute value of a, okay? This number, this absolute value of a here, this is known as the amplitude of y equals sine x or cosine x if that's, what's going on here. So if a is the number in front of sine x, that's the amplitude, okay? So it's the amplitude of that function. So when we graph this, instead of starting at 1 like we did here, we start at the 2, and we still come down to 0. And then by the time we get to pi, we're down to 2 negative. And then we come back up to 0. And then we finish off at 2, just like this. All right, so the amplitude, all right, increases from 1 up to 2. It's doubling. So the amplitude A, right, that pitch there, that's 2. Okay. Now, for a transformation where we have, instead of the amplitude affected, we affect the argument. So say we take y equal to the cosine of 3x, okay? So what's happening here? The original period of y equal to cosine of x is 2 pi. Okay, that's the original period. It takes 2 pi units to get through the cycle. As you can see here, to get all the way through the cycle, if we start at 0, by the time we get to 2 pi, we're back to where we started. Okay? Now, if I, instead of going at regular speed x, but I increase my speed 3 times, that's going to shorten my cycle by a factor of 3. Okay, so my new period for y equal to the cosine of 3x is 2 pi, but it's a third of that, 2 pi over 3, okay? So it literally shortens it down, okay? So instead of going out 2 pi for the period is only going to go out 2 pi over 3. So let me copy this and I'll send this down here. Okay. And let's see if I can do this successfully. We'll see. That's good enough. All right. So for this one, instead of going out to 2 pi, we only need to go out to 2 pi over 3, which, originally pi out here and then 2 pi. Well, 2 pi over 3 is like right here. So 2 pi over 3, okay? Now, halfway, so what did we do? If our whole period was here, we broke it up into 3 equal parts, right? So, or actually rather 4 equal parts. So half of that, that's pi, but here half of this is pi over 3. Okay, half of that is pi over 6. And then between here and here, I think we got pi over 2 right there. Okay. So what's going on here? My graph, y equal to the cosine of 3x, okay? The amplitude, the number in front is 1, so I start at 1, okay? And then as I go through, as I get to pi over 6, well, what is that? 3 times pi over 6, that's equal to pi over 2. Well, the cosine of pi over 2 is 0, right? And so by the time I get down to there, let me move this up here, to pi over 3, I've reached the bottom, okay? And then I work my way back up, and then I get to the top right there, okay? So I've literally taken this graph, all right? I've taken that graph and I've shrunk it down, okay, to 1/3. So if you look at this, if I was going to plot this in here, I should be able to fit 3 of these. If I had drawn it better to scale, then I would have put 3 of them in the time that it would have taken to get through one of those regular cosine x's, okay? So kind of cool what's going on there. This number inside the argument, whenever we change that, it adjusts the omega, the period is affected. Okay, so what we really need to figure out, is just a good way, some formula so we can figure out the period, and a formula where we can figure out the amplitude, and here it is. Okay, so if omega is greater than 0, the amplitude and the period of y equal to a sine omega x and y equal to a cosine omega x are given by the formula. Amplitude is equal to the absolute value of that coefficient in front of the sine or the cosine. Period. Okay, how long it takes to go through a whole cycle is equal to t, that time, which is 2 pi, divided by omega. Okay, the coefficient inside the argument of the sine. Okay, what's inside this parentheses is the argument. All right, so what we're plugging in for the trigonometric functions. All right, so just to make sure that we're on the same page here, if I gave you a problem and I said determine the amplitude and period of y equals 3 sine 4x, what would you do? Well, you look at the number in front, okay, the coefficient in front here. So how does it compare with our formula? Y equals a sine omega x. Okay, the amplitude is equal to the absolute value of 3, which is 3. And the period is equal to 2 pi divided by omega. So that's 2 pi divided by, well, what is it? It's 4. So that's pi over 2, period. Okay? So would it make sense that if you're going 4 times as fast as you'd normally go, that your period would be shorter? Okay, it takes less time to go through the whole cycle. Okay, that's the idea of what's going on here. All right?